Welcome, my name is Johnny Devine. I'm a nationally board certified science teacher in Tacoma, Washington. For the past few years, I've been using the project-based Knowledge and Action curriculum to teach my AP Physics 1 classes. In this video, I'll share insights and tips about the student products of Mission to Mars. In this project, students assume the role of an EDL, or Entry, Descent, and Landing Systems Engineer, tasked with proposing a tested method for safely delivering 4 astronauts to the surface of Mars. Their reasoned proposal is demonstrated at the end of the unit by testing a model loaded with 4 eggs. The project is launched by introducing students to the past challenges of putting real landers on Mars. They hear from an expert at NASA that describes the job of an EDL systems engineer. This is also a good time to introduce students to the constraints of their lander model, to form students into teams, and have them construct a quick prototype of their lander that can be used immediately in investigations. You can tailor the constraints of the lander models to fit your situation. For example, my school doesn't have a location for doing high drops, so I limit the size and mass of the lander. I also emphasize that the eggs represent astronauts, so they must be installed and removed quickly without modification, such as being encased in jello. The second task of the project focuses on the descent portion of the challenge and introduces students to the concepts of air resistance and terminal velocity. The investigations of this task make use of motion-detecting probeware and connect well with the force concepts introduced in When in Rome and kinetic concepts from Sticks and Stones. By the end of this task, student groups have designed and tested a parachute system for their lander model. During this and other investigations where students are testing their lander, I provide students with plastic Easter eggs filled with 50-gram masses in place of real eggs, which I reserve for the fifth task, Qualification Testing. This point in the project is also good for introducing one of the other main products of this project, the Validation and Verification, or V&V report, which requires students to apply physics in writing to justify all the design choices of their lander. The third task has students explore the landing portion of the challenge and focuses heavily on momentum and impulse. The investigations of this unit make use of a force plate. I have one force plate that teams share, but I've seen other teachers modify this lab to use accelerometers in place of force plates that teach the same concepts. One teacher used a free accelerometer app installed on his phone to test the acceleration experienced inside the students' landers. By the end of this unit, students should have a justified and tested crumple zone or airbag system incorporated into their lander model. The fourth task focuses on the entry portion of the challenge. Students use an energetics approach to analyze the work needed to be done on the lander by the atmosphere to bring its velocity down to a speed where the parachute can safely be deployed. This requires students to employ an understanding of power, work, the conservation of energy, and the work-energy theorem. They use the analysis to make a recommendation for a heat shield in their V&V report, since they are unable to test these ideas directly with the model lander. The fifth and final task is qualification testing, where students bring together all their systems in their lander and test them with 4 egg astronauts, or eggstronauts. This is a good day to bring in a public audience that can critique and evaluate the students' designs and justifications. Given my school's location, I've been able to have engineers from Boeing and Blue Origin. They interviewed the students and filled out rubrics that I created. Following the qualification testing, I allow my students time to include the results in their V&V report, which are turned in as the conclusion of this project. Here's some additional thoughts about the model landers that students construct. Students can search the web for award-winning egg drop designs and simply try to recreate those projects, but that is not the goal of Mission to Mars. Students should be using a rapid prototyping and iterative design process to create their landers. Do not wait until the end of the project to have students construct landers after all the physics is out of the way. Students should be constructing quick, testable modules that they can use and tweak throughout the project to not only achieve the most effective design, but also to uncover the physics as they go.